Hello everyone. This is Gayatri Priya, Assistant Professor in the Department of ECE of RMT Engineering College. In our electron devices and circuit theory, today we are going to discuss about the Zener diode as an voltage regulator. How the Zener diode can be utilized as an voltage regulator. Before getting into this actual topic, let us see what is a Zener diode, right? The semiconducting device which has the capability of getting current flow in both the directions. Yeah, your PN junction diode has the capability to produce only the current during the forward bias, whereas the reverse current is almost zero. So if I want to improvise the current flow even in the reverse bias, I want to vary the doping concentration. That is, we are getting a highly doped semiconductor device which has the capability to operate even in the reverse direction. And this is going to be the symbol of Zener diode, right? So the terminal which is closer to this ring is called cathode, the other one is going to be positive anode. Okay, even you can draw your normal p-n junction diode, okay, in the form of Z shape. The cathode should be in the form of Z shape, right? So while listing the Zener diode applications, we have mentioned that it is majorly used as an voltage regulator, and even it is being used as a overprotection circuit, and also in some sort of the clipping circuit we are utilizing this Zener diode. But the major application of Zener diode is going to be voltage regulator. So before getting into this, what might be this voltage regulator? From the name itself, we can infer whatever may be the variations, the voltage should remain a regulated one. That is, it should be a constant one, stable one. There should not be any variation in the voltage in spite of variations in any of the parameter incorporated in the circuit. Okay, then why Zener diode is specially utilized as an voltage regulator? Which parameter made Zener diode to operate as an voltage regulator? Yeah, so for that, we'll be having a constant voltage across the diode. Always the voltage across the Zener diode is constant, and this property is being utilized for a Zener diode to operate as an voltage regulator. Yes. So when coming for the voltage regulator, we have told it is going to regulate the voltage. That is, it is going to maintain a uniform voltage irrespective of the variations. So irrespective of variation, in the sense, the voltage regulations can be done in two different ways. First one is line regulation. That is, how far your output voltage is going to be constant in spite of change in the input voltage. That is, it is the ability of the power supply to maintain a specific output voltage over the changes in the input line voltage. Even though there is variation in the input line voltage, your output should remain constant. That is called line regulation. Coming to the load regulation, load in the sense whatever may be the change, variations in the load terminal, your output voltage should remain constant. That parameter is called load regulations. In the lab sessions, we have done the experiment and we have verified the VI characteristics of Zener diode. Okay. Now, let us get into the virtual exposure of your Zener diode and how it is being utilized as a voltage regulator. For this, I am just getting into this virtual lab. Okay, so type virtual lab. Okay, you will be getting www.vlab.co.in. Click on this virtual lab. Yeah, so this is a government of India initiative. Okay, it's an initiative of Ministry of Education under the National Mission on Education through ICT. Okay, so this would be very useful for us to take over our lab sessions in a virtual way. Okay, these are the very broad areas of virtuating lab, and these are the participating institute. Okay, now we are getting into this electronics communication. Here we are having nearly some 7 to 8 labs, mostly covering the digital electronics lab, hybrid lab, basic electronics lab, and analog electronics lab. Okay, so let us get into this analog electronics lab run by IIT Kharagpur. Okay, click over here. It will take to the virtual lab of IIT Kharagpur. Okay, here they have given the list of experiments. Yeah, very good. Here we are having the familiarization of resistor, inductor, capacitor, diode, application of diode, Zener diode, transistors, everything are here. Right. Now we are getting into the Zener diode as a voltage regulator. Okay, so even here we are having some theory content what we have discussed as of now. What is a Zener diode and what are the symbol of a Zener diode and how a Zener diode will be operating and how it is operating as a voltage regulator. And here it is for line regulations. Even though there is a variation in the supply, we need to maintain a constant voltage at the output side, and calculation part is being given followed by the circuit diagram for load regulations. That is, the variation in the load should not affect the output voltage. Okay, so the analytical part is being given, and even you are having some assignment oriented questions over here. So without making delay, let me get into the simulation part of this. First, I'm getting into this Zener diode line regulator. Yeah, here you are having some set of instructions. Okay, here this is the circuit diagram, a supply voltage, which we have seen in the previous tab. This is the circuit diagram. This is the source current. This is the source resistance. The source current is divided into two part once it reaches this node, Zener current and load current. Okay, so always the current is placed in the series arm and the voltage in the shunt arm. This voltage will measure you the corresponding output voltage, right? Now, let me keep this Zener voltage. You could see the variations here. And just vary this knob and making it to 5.1. And also I'm setting this row RS resistance to nearly some 1K. And I'm varying the load resistance to some uh, 2K. Okay, I have set this. Okay, now we are going to vary the DC voltage. Let it be at 0 voltage. Okay, so first value we have taken. Next, I'm varying this DC voltage. You could see the variations in the ammeter as well as the voltmeter. Okay, once I vary the DC voltage, let it make the tabulation of this. Okay, so I'm just taking some random values of DC voltage and just tabulating. Okay, so meanwhile you could see the variations in the source current, Zener current, and the load current, whatever the thing, you are having some deflections in the ammeter. Okay, so everything is being noted. So maximum I have varied the DC voltage and I have tabulated the readings. Okay, so if I see to the tabulation part, your source voltage is varying from right from 0 to 30 volt. Okay, and the load current is remaining as a constant one. Let us make a plot of this. Yeah, this is at 0 source voltage and this is at 4.2. Right, once I reach this 5.1, this is the voltage across the Zener diode. Okay, so once I reach the Zener breakdown voltage, irrespective of variation in the source voltage, the output voltage should remain constant. That is your line regulation, the capability of the power supply to maintain a constant output voltage irrespective of variation in the source voltage. Okay, even you can take a print of this particular graph. Okay, and once after you can change this load resistance or source resistance, or even you can vary this Zener voltage and you can repeat the experiment and you can find out the inference. What happens if the load is varied? What happens if the Zener voltage is being varied? Okay, so this is for your line regulation. Now I am coming back to the Zener diode load regulations. Yeah, same circuit. Here I am going to vary the load resistance. So initially vary the Zener voltage. Let it be at nearly some 5.8 volt. Let it be. Okay. Keeping the DC voltage at some 2 volt, and let the source resistance be kept at nearly some uh, 1 or 199 ohm. I'm just going to vary the load resistance. Okay, varying the load resistance, we are going to make the tabulation of the reading. Okay, I'm just varying the resistance. You could see the variations in your ammeter, that is your load current ammeter, you could see. Okay, I'm just varying the load resistance and making the readings in the table. Okay, so maximum I could vary up to nearly some, it seems 1.2k or 1.25k, like that. Yeah, so right from 150 ohm to nearly some 1.24k, you could see variations in your load current, but the output voltage remains constant as 5.8. That is the Zener voltage, whatever we have given. Make a plot of this. You could see right from nearly some 150 ohm up to your 1.236 ohm, the output voltage is maintained as 5.8, which is nothing but the Zener breakdown voltage. So that is your load regulations. In spite of variation in the load resistance, the output voltage should remain constant. Okay, even you can make a print of this particular graph. You can change this DC voltage, or I can change this Zener voltage, anything. You can repeat the same experiment and you can find out the inference what happen if the Zener voltage is increased. If I keep here a 6.1 and if I repeat the experiment, obviously I will be getting the plot of 6.1 over here. Okay, similarly you can make the inference of change in this DC voltage, RS and RL, everything, right? So this is the basic reason how a Zener diode is being utilized as a voltage regulator. We have discussed for both line regulation and load regulation, right? So whenever you are having some ample time, you just get into this basic electronics lab run by IIT Kharagpur and get exposure to the various experiments that are being listed out here. That would be useful for the theory sessions. Hope you enjoy this session. Thank you.